figures shows our laser ablation laboratories. Laser ablation ICP-NS has been very popular in China, especially for earth sciences. It was also amongst the hot topics in JAAS. Remember that laser ablation ICP-NS is also 25 years old. It has been widely used to in situ element and isotope relation measurements and age dating of heterogeneous materials in micrometer scale. It has resulted in exciting research. For example, 3 of the top 5 highly cited papers by authors from China in analytic atomic spectrometry deal with this technique. In the following, I would like to introduce some of our recent work in laser ablation ICP-NS. Zircon is one of the mostly used minerals for determining the age, origin, and the thermal history of rocks and deciphering the evolution of the crust and the mantle of the Earth. Using uranium lead dating, hafnium isotopes, and its trace element composition, we described an in situ method for simultaneous determination of uranium lead age, hafnium isotopes, and trace element compositions of zircon by quadruple and multi-collector ICP-NS connected to a single laser ablation system. For routine laser ablation ICP-NS analysis, an internal standard is generally used to correct the variation in the ablation yield during each run. We propose an internal standard independent calibration strategy based on 100% oxide normalization for analysis of minerals and glasses. The results of AMPI in glasses calibrated against our proposed method is much better than those by previous method. This article has ever been one of the top 25 hottest articles in chemical geology. 100% oxide normalization method is also successfully used to direct quantitative determination of trace elements in fine-grade whole rocks by laser ablation ICP-NS. The configuration of ablation cell have a significant effect on analytic signals. We have designed a full option and a low barrier chip for laser ablation ICP-NS. This ablation cell has 3 outstanding advantages, namely improved sensitivity, good stability, and reduce the cell-related mammalian effects. Based on our previous study, we proposed a local aerosol extraction strategy. In our proposed local aerosol extraction strategy, the gas outlet position was changed into the center of the cell. Furthermore, the gas inlet lubricant was directed perpendicular to the bottom of the ablation cell. Compared to the normal aerosol extraction, the peak height of a single laser shot was increased by a factor of 13. The peak width was reduced by a factor of 12. And the washout time for some cell was consequently shortened to approximately 2 seconds. Thereby, almost eliminates process of aerosol particles recirculation within the ablation cell. Our results show that the element distribution in different size particles appears to be correlated most strongly according to geochemical classification. The selective extraction of the different size particles was realized by changing the distance between the ablation site and the outlet extraction lubricant. Time-dependent signalation variation, so-called element fluctuation, has remained as the main focus in study of laser ablation ICP-NS. As shown in this figure, There are some significant different laser-induced element fractionation between the widely used external standards LIS-10 and natural silicate material GSE. This figure shows the calculated element fractionation index. It can be seen from this figure that it is a much less significant laser-induced element fractionation in LIS-10, which makes it not ideal as external standards at a high spatial resolution analysis of natural silicate materials. In the endless quest to enhance analytical capability, additional gas other than argon that bleed into or replace one of the three gas flows of ICP have been extensively studied. Results presented here indicate that adding small amounts of nitrogen have an important role in improving the performance of LA-ICP-NS. The sensitivity for most of inverted elements were increased by a factor of 2 or 3, while the sodium oxide was reduced by 1 order of magnitude. A very consistent increase of other signal by the addition of nitrogen supports better energy transfer effect of nitrogen in the plasma. Because of the simplicity of the method, it will be of immediate benefit for application where improved limits of detection and an increased spatial resolution is of importance. By using nitrogen adding technique, we report new results for 18 rarely determined elements in MAP-10, USGS, and the NIST classes using laser ablation ICP-NS. NIST 610 is one of the most widely used external calculators. The analytic accuracy of annual samples directly dependent on the accuracy of the recommended values of NIST 610, which in turn determine the geological interpretations of the results. Niobium and tantalum are important geochemical tracers. We propose an increase of 6% and 30% of the preferred values for niobium and tantalum respectively. We have also designed a laser data reduction software for laser ablation ICP-NS. This software is your basic micro-driving program that runs in Microsoft Office Excel. For more information, please visit our website. The third Asia Pacific workshop, time and attention.